Hello everyone. Today we will cover previous year questions. These are the real life questions that has been uh, asked in the university exam papers. So in morning statistics today we will discuss advanced statistical inference. The first question is explain the minimum variance bound estimator MVBE concept. Okay, first of all, for understanding this concept, we will have our solutions as well. In this solution, we will first minimum variance unbiased estimator. So let's see that. See, in minimum variance bound estimator, a minimum variance bound estimator is an unbiased estimator that achieves the lowest possible variance among all unbiased estimator for a given parameter. Suppose you have two estimates, theta 1. So if you have two estimators, these are two estimates, suppose, and the estimates that got the minimum variance that will be discussed in MVBE. Suppose theta 1 has the minimum variance than theta 2. Then theta 1 will called MVBE, minimum variance bound estimator. So that was here has been discussed. A minimum variance bound estimator MVE is an unbiased estimator. Suppose these are the two unbiased estimators that achieves the lowest possible variance among all unbiased estimator for a given parameter. So for more specifically, not all unbiased estimators, it will be discussed within two unbiased estimator. If it is all among all unbiased estimators, then it will be discussed in UMVBE. So it is more specific way. Okay, so we will discuss it later. For your kind information, why not now? See, has been a difference between UMVBE and the difference between the MVBE. For minimum variance between two estimators, then we will discuss in MVBE, and minimum variance among all unbiased estimators, then UMVBE. It will be called UMVBE, stands for uniformly minimum variance unbiased estimator. It is the statistical property that defines an optimal estimation method for an unknown parameter is a probability distribution. In the context of a statistical inference, UMVBE is a type of estimator that is both unbiased and has minimum possible variance among all unbiased estimators. That means that UMVBE strikes a balance between being unbiased, for example, picked value equal to the true value of a parameter, and it will be expected value equal to the true value of the parameter, and having the smallest variability, making it efficient and desirable estimator. The Lehmann-Scheffé theorem also very a simpler method for finding this UMVBE. Okay, that is not my concern for right now. My concern for right now is MVBE, and I already mentioned that. What is MVBE? When you have two unbiased estimators, then the minimum among them will be called MVBE. There is a written some of the not a specific one. It's moreover UMVBE. So I just clear it right here right now. So for UMVBE there will be two, not all. Okay, so there is a method called CRLB, Cramér-Rao low bound, and this method provides a theoretical lower bound to find out the minimum variance. So if this one has been satisfied, where I theta is a future information and the parameter of interest is the greater than or equal to this quantity, then we will say that yes, it is MVBE. Okay, now our second question. Okay, our second question was discuss the necessity of Cramér-Rao lower bound in connection with the MVBE. So we have to discuss CRLB. Already had been done here, because CRLB provides a theoretical bound. To find out the MVBE, we need CRLB. So, in formal way, the Cramér-Rao lower bound is an essential context of minimum variance unbiased estimator, because it provides a theoretical lower bound on the variance of any unbiased estimator. This bound helps in determining whether an estimator achieves optimal efficiency. If an unbiased estimator attains the CRLB, it is considered an MVBE, indicating that it has the minimum variance among all unbiased estimators for a given parameter. So, simpler way, it's a way to find out this MVBE, and the way is discussed in mathematical formation like here. Next one, the next question has been asked here is that is this concept adequate to find the UMVBE? See, we can find this CRLB with MVBE, but we doesn't uniformly minimum variance unbiased estimator. No, why? The CRLB alone is not sufficient to find UMVBE because it does not consider sufficiency. The major objective here is this sufficiency that we need, but CRLB does not provide this one. To find out this UMVBE, we need the sufficiency and completeness, which is the key requirement for UMVBE. Instead, techniques like Lehmann-Scheffé. Lehmann-Scheffé is the easier technique to find out this one. Okay. And Rao-Blackwell theorems needed to formalize to derive this one. Okay, so we have done our first question, A. I think it's quite enough for that.